Precalc, this is 1.7. We're going to talk about inequalities today. And I think if you haven't printed off, there's a few slides in here that will make your life easier if you have them printed versus not printed. So remember, inequalities, guys, use the four symbols: greater than or equal to, greater than, less than or equal to, and less than. We'd use those instead of an equal sign. So now we're going to take equations and make them inequalities by replacing the equals with one of those four choices. Remember the names of them. If you need to, make sure you write them down. We don't say the alligator's mouth opens this way and say, oh, the one that opens to the left or to the right with a line under it. We want to use the correct name of those. So, to solve an inequality that contains a variable means to find blank of the variable that make the inequality blank. Okay, true. I think it would be definitely the second one. So to solve an inequality that contains a variable means to find all solutions. All solutions of the variable that makes the inequality true. Because remember, guys, we're not just finding one solution. When it's an equal sign, it's equal to 5. It's equal to 3. Now we're going to say it's greater than 3. So that any number that's greater than 3, 3.0001, is a solution to that. Now when I say x is greater than 3, so x is greater than 3, is 3 part of that solution set? No. Because it's not equal to. So to solve inequalities, we use the following rules in the box there of adding, subtracting, multiplying, and dividing, taking reciprocals, and so forth. These rules you guys have seen before. That basically says that I can add or subtract from an inequality as long as I do it to both sides. I'm perfectly fine. Multiplying and dividing, the same exact thing, are all the same rules that we've always used. The biggest thing about it is in 3 and 4, you're multiplying, guys. And if you're multiplying both sides of an inequality by a negative, you need to do what? You need to flip the inequality. But that only happens when multiplying or dividing by a negative. Because remember that dividing is the same thing as multiplying. And one that kind of is interesting here is taking the reciprocal. So if I had a fraction is greater than or less than, it doesn't matter, another fraction, and you can see that, at least in this case, that the variables are on the bottom, we could flip them to the top, or if they're on top, to the bottom. But when you do that, you also need to flip the inequality. Because think of this. If the larger the number is, if I divide it into 1, the smaller the number gets then, right? So the larger the denominator, the smaller the number actually gets. So when if A happens to be, well, in this case, we're talking about, B being bigger than A. Since B is a bigger number, if I flip that and make that onto the underneath 1, that means it actually will be overall a smaller number. So just be mindful of that. Okay? Any questions? So we're just going to use those rules. Again, they're pretty simple. Things we've used for equations all along. Again, flip the inequality when multiplying or dividing by negative. So all I want you guys to do is solve this inequality. And then maybe we should graph it as well. I know we did a little bit of graphing in 1.1 or 1.2 or something around those lines when we talked about interval notation versus inequalities. So if I want to get x by itself, I think we can see that we should probably move 3x to the right, correct? And if I move 3x to the right, is that okay? What's on the left then? It's not nothing, it's 0. So 0 is less than 6x plus 4. And now, subtract 4. Now this is not the only way that this problem could have been done, as in I could have took the 9x and brought it to the left, and then just divided by a negative. You guys will see that it would end up being the same. Divide by 6, divide by 6. So x is, whoops, not equal to, bless you, greater than, or x is greater than, or we would say the other way around, negative 2/3 is less than x. Everybody gets that, right? Now, just for fun, let's make a graph here. And if I make a graph, guys, for me, as long as you can demonstrate that you can get your critical points and your shading to the correct side, I'm okay with just putting a negative 2/3 there. You have to decide, is this an open dot or a closed dot?
Open.
Why is it open? It's not equal to, so it's an open dot. And which way do I shade?
To the right.
To the right. Now, there's a lot of people who are looking at these, or have always been taught that it looks like this is an arrow, and so you shade whatever way that arrow is pointed. But that would be to the left. But everybody's telling me I need to shade over here. It only works, guys, if x goes first. You put your variable first, and then it kind of tells you which way to shade. But, here we go. Watch this. Where would 0 be on this number line?
To the right.
To the right. So 0 is someplace over here. To me, what I would want to do is check a point. And if it works, I shade that side. If it doesn't work, I have to shade the other side. If it's not heads, then it has to be tails. So that's the kind of thinking that I'm using here. So is 0 greater than negative 2/3? Is that true?
That is true.
That is true. So therefore, I will shade to the right.
That's how you want us to check it first, Rob?
Yes, I would want you to check an actual point someplace. And if 0 is not one of your endpoints, 0 just makes things way easier. The next type of problem is what happens if there's two inequality symbols with some stuff in the middle or someplace else. All of the rules that we just saw apply here. Instead of what you do to one side, you do to the other. It's what you do to the middle, you do to the outsides. So the first thing I need to do is get rid of the what? The 2. And to get rid of the 2, I just add 2 to all three parts. So 6 is less than or equal to 3x, which is less than or equal to 15. And now divide everything by 3, 2, less than or equal to x, which is less than 5. And to graph that, critical points at 2 and at 5. Make sure, guys, when you go to graph these that your number lines are in order. They very well could have put 5 is greater than x, which is greater than or equal to 2, right? They could have done this. That means the exact same thing, right? It's like someone picked it up and just flipped the whole entire thing over. Perfectly fine. So just be careful that you have your stuff in the right order. Is 2 included?
Yes.
Yes. 5? No. And
X is in between.
it happens to be in between. So you can kind of see this is a compound inequality, which means it's from 2 all the way to 5. So yes, I should shade there. Now, going back to this whole idea of checking a point. 3 is definitely in the middle, yes? Is 2 less than or equal to 3 but less than 5? Yes, so I'm going to shade there. Wait a minute. 0 is someplace over here. Is 2 greater than or equal to 0? No, but it is less than 5. It doesn't make the whole thing true, so therefore I'm not shading on the left. I could do the same thing with 6. Okay, it has to fit within that range. So yes, it's just from 2 to 5. Notice I use a squiggly line because if I drew a straight line, you guys probably wouldn't even recognize that it was there. So I just kind of either boldly shade it. Some of you guys might want to, do something like that on your number lines so you guys can demonstrate that you guys do know what you're doing. So another thing that you guys should know is that the sign of a product or quotient, if you take the product or multiply or divide negative numbers, and there's an even amount of those negative numbers, an even number of negative numbers, then its value will always be positive. A negative times negative is a negative, 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 still positive. Now, if that same idea happens and there's an odd number, like 3 of them, a negative, 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 the value will be negative. We know this. We've used this before. So the thing about this one is that now you have a quadratic, and we all know, guys, that quadratics should look like this, which very well could pass through the x-axis, which means these spots right there are the solutions to the quadratic. But we're not looking for specific solutions. We're looking for where is it less than 0. So quadratics will have some parts above the x-axis and some below. And so how can we do this without having to graph it? Well, what we'll do is we will just factor it. It's x and x. What are the factors of 6 that'll give me 5? Has to be
-3, -2.
both positive or both negative. But the middle's negative, so that means they both have to be negative. Therefore, 1 and 6 would not be a good option, right? So, we have our factors. That means our critical points would be where? X equal 3 and x equal 2. Now those are switched. I heard 3 first. Which means when I go to put this on my number line, 2 goes here, 3 goes here. Are these equal to or not equal to? Are they included or not included? They're included because the sign here says that it can be equal to 0. So they're both included. Now, we could just go with this idea of checking points, because that's what we need to do. But again, there are 3 different areas. There's an area over here, an area in the middle, and an area at the end. All I'm asking you to do is find 3 points and check it. Because the bigger the polynomial starts to get, the more chances that it can be above or below. Because if you guys think about what a 5th degree polynomial looks like. A 5th degree polynomial, if you remember, is one of these things, right? So it could eventually be above and below quite often. But anyways, so over here, I'm going to change colors so we can see it. I think 0 would definitely be a good option. What's in the middle between 2 and 3 somewhere? 2.5. And stick with something nice, 4. All I'm going to do, guys, is I am going to place those into here. And I'm going to use the rule above that says I'm not even going to actually figure out the value. I'm just going to find out what the sign is. So what the book does, if you want to do it this way, is they just create a table. And in this table, they put in things like, they set up a table that puts the factors on the side with the results, so the resulting sign, and then they put the values that you're checking in. So I'm going to put 0 in first. X minus, or 0 minus 2 is going to be what? So it's going to be negative. That's all I'm going to care about. 0 minus 3, negative. The sign resulting when you multiply those together is positive. 2.5. If I subtract 2, I am
Positive.
positive. If I subtract 3,
Negative.
so my result would be negative.
4.
Positive, positive, positive. So, this table tells me that in the 0 area, it's going to be positive or above the x-axis. It's going to be less than or negative at the 2.5 area range, and at 4, it's going to be above. So, which one of these, or which one or more pieces will satisfy the fact that this thing needs to be less than or equal to 0? Where does that happen? In between. So I shade in between. What we need to do here is just the guidelines is move all terms to one side. Yeah. Factor. Yeah. Find the intervals. We just did that in the last problem. And then we make that table or diagram, and then you can solve by making sure that you have the inequalities right and those things. So it's kind of a little sum of what we just did, but we're going to obviously go into a little bit more in-depth problem. So in this example, the inequality has a quotient, aka fraction. When does 1 plus x over 1 minus x greater than or equal to 1? For what values? Okay, so we're taking a guess, or you think you know?
No, that's for sure.
For sure. Okay. Let's figure this out. According to the rules on the last page, you need to get everything to one side, or really on the numerator. Solve for x is what happens to be. And to make that happen, multiply both sides by the what? I don't like fractions. The denominator in this case, or the LCD. Oops. So 1 minus x gets multiplied to this side and 2. So these cancel out, yes? So 1 plus x is greater than or equal to 1 minus x. Can you solve for x then? I think I'm going to add x. And subtract 1. So 2x is greater than or equal to 0. Divide by 2. Do I need to flip the inequality? Why not? Because it's positive. There's my answer. The answer is when x is greater than or equal to 0. So 0 would work. 1 works, 2 works, 3 works. Again, if I was to graph that, here's 0, it's shaded, and it's greater to the right. Next problem, I'll give you guys a couple seconds, try on your own. First step I should do is what? LCD, or multiply by x minus 1, x minus 1. They're gone. That's nice. So I get 2 on this side is greater than, bless you, what? I'm going to move that over. X squared minus x. When I distribute the x in, probably should do what now? Subtract 2 and factor. So x squared minus x minus 2 is less than 0. This one's going to create a table, right? Not too bad of factoring on this one yet. What are the factors of 2? That'll give me a negative 1. Negative 2 plus 1. So x equals 2 and x equals negative 1. Shouldn't take much to think of those, right? So let's go make a table. maybe we should graph them on a number line first so we can pick our values. Which one goes first on this number line again? So -1, 2. Are they open or closed?
No, open.
They're both open. So now let's just pick some values. -2, 0, and 3. Okay. So let's make a table. I'm going to put -2, 0, and 3 in to our factors of x minus 2, x plus 1. And we'll call this our sign because that's when we're multiplying them all together. That's the important row. What happens when I put -2 into x minus 2? It's a negative. Into x plus 1? Negative. So our sign will be positive. Putting 0 in. Negative. Positive. Negative. Positive. 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 So, the question is, again, where is it less than 0? And the only place they are less than 0 is again in the middle. If that sign would have been switched, then we would shade the outsides. Getting close to finishing up, now we just have to talk about absolute value inequalities. The biggest thing about absolute value inequalities is I don't like the absolute value in the inequality. And so what you need to do is say, hey, if I see this side, my first step, as I have it listed below, is isolate the absolute value. I need to set it up so the fact that it is looking like this. Now remember, this is absolute value of x. We also could be the absolute value of 5x minus 2. Whatever is inside the absolute value is what x represents right now. And if you can make it isolated to say that's less than c, then you can switch it to this, which is x is still less than c, but it's also greater than the opposite of c. And hopefully you guys just kind of remember that from Algebra 2, maybe even a little bit from last year. If it's greater than or equal, less than or equal to, it's the same exact thing, but we have it equal to as well. And these are the same, but when it's the absolute value is greater than c, we actually have an or because it's here or there, and it's x is less than the opposite of c, or c is less than x. The biggest thing, guys, when you're switching out of absolute values, you can see that whatever this is, if I just drop the absolute values, that's half of the equation, or half of the inequality that results. Because if I drop these absolute values, I get x is less than c. There it is right there. But you have to worry about the other end of it. And the same thing here, where the absolute value is greater than c, x is still greater than c right there. And then you have the less than the negative c. You're flipping the inequality and making the c value, or the value it's equal or greater than, opposite. So again, the steps here are isolate it, switch it, and then you can solve it using the rules from before. Because we could solve all these. And if you get a compound inequality with an or statement, you just solve them individually, and then you can graph them. This is an and, because there's a way to write that as an and as well, using the same exact process as 3 and 4. They run together, right? It's a range from here to there. The or statements are outwards. They go away from each other. And so, I got two examples. One that does the and one does the or. Solve these ones. I'll do the first one with you guys. The second one I want you guys to try on your own. Okay, so the first one, guys, you got to recognize that is a less than. It's not less than or equal to. The sign, the inequality signs don't change. So if I go back real quick, that would deal with the first one. So I'm going to drop the inequality and then place it greater than the opposite of c as well. So right away, I know that the absolute value is by itself, number one. There's not a 2 or a 3 out front or added or subtracted to the absolute value. That means right now I can put in here that x minus 5 is less than 2. I just dropped the inequalities. Or the absolute value. Sorry, absolute value. Just get rid of them. But then I also need to realize that there's the other end of that, and that means that I have to be also greater than the opposite of c, which is 2, so the opposite of 2. And from here, goes back to one of our first examples of the day. Solve it by what? Adding 5 to all 3 sides. So 3 is less than x, which is less than 7. There you go. Guys, here's a cool thing. We know that 5 is a solution. 4 is a solution. 3.01 would be a solution. You could check those up in the original inequality to make sure you're right. I'm not going to graph that now, but you guys could graph that. Try the same thing with the other example there. Recognize the absolute value is already isolated. And so 3x plus 2 is greater than or equal to 4. Now this is a greater than one, so it's or. I like to just keep it the exact same, but then say it's also less than or equal to the opposite of 4. And then solve these individually. The cool thing about solving these individually is that the same steps are involved. Subtract 2, divide by 3. So subtract 2, happens to be straight across the board, so 3x is greater than or equal to 2. 3x is less than or equal to negative 6. Divide by 3. I ran out of room, I'm sorry. So therefore x is greater than or equal to 2/3. Or x is less than or equal to negative 3. And if you were to graph these, they would be going away from each other. This should be a negative 2 here. So now we're starting to get into the word problems using inequalities, and this kind of goes back to kind of real life. You guys very well could go to a theme park and want to buy tickets for a ride, or you could maybe buy a wristband for so much. How many rides would you have to go on to make the wristband, which usually costs more for unlimited, right? Or a reduced price? How would that, benefit you? At what point would it benefit you? And so what we can do here is say, how many rides would it take for plan A to be less expensive than plan B? So essentially what it comes down to, plan A should be less than plan B, correct? That's what we're trying to figure out. Do you have enough information to create some kind of cost for plan A and plan B though? $5 interest fee and 25 cents a ride. $2 interest fee and 50 cents a ride. There's going to be a break-even point, right, where the amount of rides will make this, doesn't matter, but as soon as you go one more ride, you should have went with A. What is that? What is the cost for plan A? The faster we go on this, the faster you guys get going here, guys. A. 5 plus 0.25x should be less than 2.5x. I'll let you guys solve that, but there will be a break-even point, which allows me to say, hey, at this many rides, which will not be a solution to this problem because we're less than. But we are trying to find out at what point does it tip for plan A to be more cost effective than plan B. This one as well, we'll set this one up, but we're not actually going to do it. The instructions on a box of film indicate the box should be stored at a temperature between 5 degrees Celsius and 30 degrees Celsius. What range of temperatures does this correspond in Fahrenheit? And the relationship is the equation of C equals 5/9 times F minus 32. Well, first of all, Celsius is between what? 5 is less than or equal to C, which is less than or equal to 30. Wait a minute. Do we have anything that converts those? C happens to be in terms of F. What is it? 5/9 of F minus 32. So could I just replace that? And in this case, multiply first by 9/5. Multiply by the reciprocal to get rid of it. And then add 32. And you would have your Fahrenheit. 1.7, page 87, 1 through 85, every 4. Have a great day.